morning, everyone. Thanks for joining us bright and early for today's webinar. We'll be looking at qualified fenestration products in Canada. We're joined by Adrian Edge, Director of Codes and Regulatory Affairs with Fenestration Canada. And I'll just be giving a quick introduction here. The following slide there, please. All right, so I'm calling in from what is now known as Cristova, but for thousands of years has been the traditional homeland of the Sinixt Nation, the Silks Nation, and the Ktunaxa Nation, and is home to the Métis and diverse Indigenous peoples. I'd like to express my deep respect and gratitude for the generations of stewardship of these areas, waters, mountains, forests, and that has kind of allowed us to enjoy and feel connected to our natural environment in the way that we do. As part of CEA's commitment to truth and reconciliation, we recognize the importance of amplifying Indigenous climate leadership. So I'd just like to start off this morning and take advantage of this opportunity to highlight a story of Indigenous leadership in the high performance building space. So in 2013, the Penticton Indian Band had a growing population and not sufficient housing supply. So they connected with landform architecture and design build to address the shortage and provide a template for future provisions of housing that are more durable, comfortable, and sustainable than what was being built in the past. So 8 homes were constructed. 6 had EnerGuide ratings of 88, 1 had a LEED Platinum certification, and 1 had a certified passive house certification. So all homes are oriented to the south for maximum passive solar heat gain with natural cross ventilation and generous overhangs, and included energy efficient HVAC equipment and appliances. Native landscaping provided continuity with the surrounding grasslands, and it also eliminated the need for irrigation and maintenance. Materials used were durable, requiring little maintenance, and were resistant to wildfire. So just to close with a quick quote from their website, they said, "Our efforts to reduce the energy use of the homes not only reduced heating costs, it connects us to the timeless and traditional ways of building, which relate to the movement of the sun, natural breezes, and the Indigenous landscape." All right, and then one last slide for me before we pass things over, just for those of you who are maybe joining us for the first time and you're not familiar with the Community Energy Association. Well, CEA is a registered charity and nonprofit that accelerates bold action by local governments and Indigenous communities on climate and energy issues. So BC local government know that businesses in their communities need access to training to meet the growing demand for high performance homes, and that's where CEA comes in. So since 2017, we have delivered high performance building training to the contractor and builder communities. We work through a number of different programs you may have heard of already, including the Kootenay Clean Energy Transition, Building a Legacy North, and Retrofit Assist. All right, and so with that, it's my pleasure to pass things along to Adrian. As mentioned, Adrian Edge is the Director of Codes and Regulatory Affairs with Fenestration Canada. And before joining Fenestration Canada, Adrian worked with 2 vinyl window and door manufacturers in Vancouver, BC, and previous industry expertise lies in multifamily projects. Adrian has developed various departments, including installation, sales, and project management, and now oversees code changes to assist manufacturers, governments, and other construction stakeholders to build a better fenestration industry in Canada. All right, thanks for joining us this morning, Adrian, and over to you.
My pleasure. And thank you all for participating in this. I will admit 90 minutes of compliance discussions around windows and doors, probably wouldn't have attracted me if I wasn't obsessed with this space. So yeah, thank you again for everyone participating. I got a chance to kind of see the list of participants before we got started, and you are a diverse bunch. So I have done my best to kind of review the presentation and make sure there's a little something in it for everyone. There's going to be 3 moments in the presentation where I'm going to take questions. So we'll get into interior and exterior environment, and there's going to be an activity for both of those. I'll give some space for us to ask questions so you can kind of clarify certain points at each one of those breaks. And at the end of the presentation, I'll also take questions. For anybody that didn't quite get your question in during the presentation, don't hesitate to reach out. I'm going to leave my email at the end of this, so feel free to reach out. I'm always happy to answer any questions that you guys have. So to kind of walk us through what today's going to look like. Why? So first, I'm going to talk a little bit about what the regulatory landscape for windows and doors looks like. Admittedly, it's been a bit of a journey for me to understand how we are being managed, meaning, what is the different government levels of expectation. So I'm going to start by kind of giving a description about that, and then throughout the presentation, I'll give specifics relative to certain elements so that they are applicable. Next, we're going to go through a whole area specific to interior factors of window and door compliance. I'll explain that in a slide here in a moment, as well as the exterior factors. But we're really talking about the inside of a building and how well it maintains its environment versus how well the product helps resist elements from the outside. Then we're going to get into a whole section specific to specifications and the areas of windows and doors that really only show up in regulatory space because of a specification that's written. But it makes a huge difference when in very rare and Part 9 buildings or small single family homes, and then non-Part 9 buildings or Part 3 buildings or multifamily. Then next, we're going to talk a bit about installation. I'll admit this was a kind of a tough one to add to this conversation because there isn't a lot of regulation around installation, which is why I felt it was so important for us to kind of lean into it because it is one of those areas that's really critical to, windows in a building, but there's just not a lot of guidance around it. So I'll provide a little bit of education about that. And then last, I'm going to go over some future considerations. I'll admit, in the 10 years I've worked in the industry and the things that have been going on, and then, mentors of mine and industry leaders that have been doing this for 30, 40 years, we live in an interesting time where there's a lot of moving parts. And so my hope is that I can give you a bit of insight on, what the next 5+ years are going to look like as far as regulation in our space. All right, so right off the bat, as I mentioned, I'm going to kind of talk about, the regulatory pyramid. So right at the top of the pyramid are acts. So acts are legal requirements for an industry. Most industries have an act that's applicable. In the window and door market, we actually only have one in BC. That everywhere else in the country, there are no acts that are applicable. There used to be an Ontario Act, but that's actually been rescinded. And so that is no longer a applicable act for our purposes. So acts are interesting in the sense that they typically act as point of sale requirements. So they hit certain things that say you cannot sell this product unless you meet X requirement. It also gives enforcement levers to the province and to the federal government to be able to determine, if the product is not meeting that compliance, how they deal with it. So that's kind of a unique thing in the big scheme of things, because as we go through the rest of the regulatory framework, you really don't have those levers very instinctively built in. So codes are obviously the most common item that we're going to be talking about when it comes to regulatory framework. It is really where most of our requirements on the window and door side come from, or at least explicitly. They are the thing that we all kind of go back to, and they say, okay, this is a minimum requirement for a particular area, whether it be the NBC's model code or the provincial codes. Um, then we'll get into a little bit about specifications. So specifications are an interesting regulatory item in the sense that, there isn't the laws and the intent necessarily legally to put them in place, but when a multifamily project creates specifications and they start calling out different metrics that you need to meet, that becomes a regulatory item for that specific project. You wind up having to meet them unless an architect or a designer decides to back off of it. Then next is standards. And standards are an interesting thing for me when it comes to thinking about it as a regulatory item. I've got a slide here in just a moment that I'm going to explain why it is, but let's just leave it here for now so that yes, it is a regulatory item. And then last, and probably the oddest of the pyramid that is regulatory space, is guidelines and policies. Um, there is regulations. What oftentimes will happen, why guidelines and policies become regulatory, is because codes and acts and specifications will start calling those things out. they will say, you need to follow this particular guideline or this particular policy or this best practice guide. So I've got an example of this that I think is kind of interesting to kind of see how guidelines become regulatory policy. But yeah, anyway, that's kind of your pyramid of regulatory space. Um, and I also wanted to do a little bit of a service to helping this group understand the difference between like a Part 9 building and what is called a Part 3 building. You'll often hear me say a non-Part 9 building because calling it Part 3 is kind of comical, at least in my own space. So in the window and door space, if we're looking at a multifamily building, you're actually regulated by Part 3, Part 4, Part 5. So yeah, I'll call it a non-Part 9 building. So for Part 9 buildings, these are small single family dwellings. They are meeting a certain amount of square foot space. And and really, your codes are going to dictate a prescriptive method. At least that's the intent. Part 9 was always kind of designed as a paint by numbers type of system that you've got prescriptive requirements that you need to meet in order for that building to be signed off by an authority having jurisdiction. Over time, that has become more complicated. There is some serious discussion, especially in BC, about what that future looks like. That we've got elements within windows and doors that really become more performance managed than they are prescriptive managed. And there's going to be continued conversations about that as we move forward because it really did kind of change the way Part 9 works. But in whole, Part 9 kind of leaves you with you need to have labels on your products. Your safety glazing has certain minimum requirements, and there's some basic documentation that a project will ask for, but ultimately it's a paint by numbers system. And then Part 3 is going to be a bit more complicated that because you're going to have consultants involved, engineers involved, there's going to be a shop drawing phase that the window and door manufacturer is going to have to go through in BC and growing throughout the rest of the country. You're going to have Schedule B and Schedule C. So these are going to be professional sign-offs that have to happen. You're going to have mock-up testing, which again, I'll talk a little bit more to this in installation, but is absolutely critical because of how much risk a multifamily building is going to take on. You're going to do water testing in many portions of BC. You're starting to see air tightness testing. Toronto has some of it showing up. Alberta has some of it showing up, but you are seeing a growth of the envelope consultants around multifamily buildings. So, and then you're going to have specifications that really call out specific things that are really beyond the code requirements or the act requirements. So, yeah, I kind of mentioned this in our summary, but we've got two areas that we're really going to focus on today. So first is the interior environment. That is going to be how well your envelope maintains the interior space. So, can your window and door keep the heat in or the cooling in? How much sunlight is going to add heat to that interior space? How clear is the glass that you're going to be seeing through? And what is the resistance to condensation for that product? That's kind of interior environment. And then exterior environment is going to be dealing with, how well your product resists the outside pressures. So that is going to be any of your air loss or water penetration or structural support, how well your window holds up under stress. There is also a little bit of hardware operation. I kind of loosely call it durability of hardware, but it's the wrong word to use. Ultimately, it's going to be like how well does your hardware resist use? So it's a bit of an outside the exterior environment, but it kind of sits within that certification or the testing schema. Um, and then last, I've got a series of other regulated metrics that I have a hard time putting into interior or exterior environments. So, sound is going to be one of those that we can talk a little bit about. That's almost exclusively in the specification space. Egress and safety is one that I really wanted to spend more time unpacking, but as I had the handful of slides that were related to it, I found myself spending 20, 30 minutes trying to explain all of these pieces. So I'm actually not going to get too deep into the egress safety conversation. There's a little bit of like glass safety that we'll talk about. But if you have any additional questions about that throughout the presentation or after the presentation, don't hesitate to reach out. And then last is carbon. And I'll admit, I'm kind of putting carbon into this conversation because it's an early education item. I think our industry is probably underprepared. Windows and doors specifically, but probably construction as a whole is a bit underprepared for global warming potential conversations. But I think it's really important that we're starting to talk about it because even in the 2030 cycle that we are now starting the work for, we are starting to now look at what the possibility of like component embodied carbon numbers would look like. So I'll explain a little bit of that, where that's going. It will not be the end all be all of that presentation. That really needs to be its own unique thing, but at least I'll get you started. So, as promised, I'm going to have a little bit of conversation about standards versus regulations because this is an interesting piece that I kind of struggle with, if I'm being really frank. So, in an ideal world, what should be happening is that the regulations give us explicitly what must be done in a building whenever you have a product. So that would give the means and methods to dealing with what that product needs to do once it's in the building. So, and then standards, ideally, should be test methodology that provides the metrics that define certain aspects of that product that is applicable to how it's supposed to be used. I'll admit that's not necessarily what's happening in a lot of cases. That when we talk about like NAFS specifically, it gives us a lot of instruction on what should be done with NAFS. So NAFS is the North American Fenestration Standard. I'm going to spend a lot more time talking about it here in a minute, but it defines the structural air and water tightness of a product. It also tells us when we are going to be applying labels, and it tells us a little bit of how it is to be applied. So, in the truth of it, the regulations have actually offloaded a lot of their responsibility to the standard. And so you get kind of this confluence of what the standard should be doing, what the standard is doing versus what the regulations do, which I think is sometimes why NAFS can be kind of a complicated thing for people interacting with it, is that a lot of the requirements are actually embedded in the standard itself. And so yeah, we'll talk a little bit about that, but I just kind of want to frame this first because it is where things get a little complicated, in my view. But regulations, the reason standards become regulatory items is because regulations say, hey, this standard is now a item you need to be following. So it starts creating, it takes that language of the standard, which is oftentimes like a best practice concept. It's like in the industry, this is kind of what we expect from this product. This is what it should be doing. If I do these test methods, I'm going to get these metrics. So anyway, long story short, we're going to talk a little bit more about NAFS and CSA 440.2, but I wanted to give you guys that framework to start with. So let's start into the nitty gritty of this conversation, which is starting with interior environment. So interior environment is regulated on the basis of U value, and in BC, only U value. But we'll talk a little bit about what specifically needs to be on the label. But when it comes to the metrics that you're going to need to prove, your U value is the only piece that you need to worry about. When you get outside of BC and in especially at the National Building Code, the Energy Star system has what's called an ER rating or an energy rating. That is recognized as an energy compliance path through Part 9. So you'll have like an ER rating that you could meet in lieu of that U value. I'm not sure how long that will last. There is definitely some signs that some of that needs to change. And a portion of that is that solar heat gain coefficient, or how much solar radiation is coming through that glass and being added to your interior space. There are some restrictions coming in the next version of the code. So the issue that we, oftentimes the industry has with an ER rating is that it prioritizes as much heat through that glass as possible, that the way the calculations work, it almost views it like free energy. So, in Vancouver, for instance, or in Toronto, that's really tricky because your environment's actually pretty warm to begin with, and if you start adding heat, that can create overheating potential. I've got a slide that I'm going to do my absolute best to simplify, that it actually came out of another presentation, but bear with me. We're going to get into a deeper conversation about solar heat gain. But for your guys' purposes, U value is really your regulatory item. Solar heat gain is coming. ER, when you get outside of BC, is still an item. All right, so energy efficiency acts. So as I mentioned, there's really only one, and we have it here in BC, that the BC Energy Efficiency Act dictates a point of sale requirement that no windows or doors can be sold into our market with a worse than 1.61 watts per meter squared number. So, U value is, if you have a higher number, it is a faster loss of heat. If you have a lower number, you have a slower loss of heat. I know that oftentimes it's easier to view this as lower is better, but I think it's actually really important that we think about lower is slower instead. So this requires mandatory product testing. Then there is energy certification and labeling, or testing and labeling. So you have to label your product in BC. And this act is actually one of the very few things that help create that requirement outside of the standard telling you have to label it. Um, so there, there's a lot more to kind of poke at about this. As I mentioned earlier, acts are one of those few places where enforcement levers are kind of built in. So the province or the Ministry of Energy and Mines has the ability to say, if you've got a product that's in the market that's less than 1.61 and it's manufactured, I should specify that, then you can actually have that window rejected at site, or it should be rejected at site. It is a legal requirement. As I mentioned, Ontario actually did have a regulation or a act, but it was rescinded. It was pretty similar to the Energy Efficiency Act, but the U value was 2.0. Or an energy rating of 25 or less, but that's been redacted over the last couple of years. All right, so when it comes to energy efficiency, the where you're going to be kind of looking to make sure that you are being regulated, in the NBC, that's going to be 9.36, and 9.36 is also going to be where you originally look for BC. I'll talk about provincial variations here in a moment, but let's start there because it gets weird once we get to BC. And then for a Part 3 building, you're going to be looking at Part 10 or the NECB for determining energy efficiency requirements for products. Again, when you get to Part 3 buildings, a lot of this is performance based. So it's going to be a energy advisor that is going to be helping kind of sculpt what the window requirements are, given the context of, what you did with your walls and what you did with your insulation and what you've done with the rest of your envelope requirements. So when it comes to provinces, BC is absolutely its own beast. It is so hard for me to help people understand outside of BC how BC works. The BC step code is my example of a guideline that has become a code. So, just because I think it's kind of interesting, the way that worked is that the BSSB uses what's called an OIC, so an order in council, in order to take this guideline and then apply it as an amendment to the code. And so, the OIC is oftentimes used as kind of a fail-safe measure to kind of convert critical items. So in BC, we have our BC step code, and it's a voluntary effort. So each municipality gets to choose what step they wanted to play in. Up until the last couple of years, where that change in the BC step code because of the OIC was then implemented for an absolute tier 3 baseline requirement. So all of the municipalities have to meet that tier 3 or that step 3 requirement. So What that did in principle is that puts us with three requirement metrics within BC. We have the AX, which is 1.61, like you absolutely cannot sell at that level. You have the BCBC, which is requiring a 1.81 for a zone 4 requirement, which is kind of superseded by the Act. And then BC step code, which it doesn't have, like it has different compliance paths, but ultimately, what you wind up doing is a absolute bare minimum of like 1.4 is kind of expected. And this is kind of a loose way to describe that, but that's why BC is kind of it's its own beast. It's unique in the sense that it has these different layers that you have to deal with. So then in Ontario, they have SB10 and SB12 are their energy requirements. So that's going to define what you have to do in Ontario. And then Quebec has their own energy efficiency table. It's actually kind of worth taking a moment to explain harmonization. So for those that have been kind of in the background hearing about the code being harmonized, I just want to make sure it's clear what that actually means. So there are accords that were signed by each province that said that they would work towards harmonization of the national building code, our model code, down to the provincial codes. What that means in practice, and especially for this last cycle and probably this cycle coming up, is that the provinces will do their best to remove what I'll call provincially specific artifacts. They are items or ways the code is written in their province that is unique, that really has very little bearing or difference from what the national building code does. And so, a lot of the work that BC specifically has done is remove so many of those artifacts so that it is as aligned to the national building code as possible. Um, I think there's a misconception about the provinces needing to essentially adopt in full the National Building Code. That is not what's being asked of the Accords. What is being asked is that is close to that as possible. And if you have legitimate policy directives, then you can make differences to that, which actually gives the provinces a voice back to the National Building Code, that it allows kind of for this push and pull between code cycles where, one province like BC will have items that they feel are really important. And so they'll bring that back to the National Building Code, like, hey, we don't want to change this because this matters to us. And so then the National Building Code reviews it and decides whether or not that's appropriate for the rest of the country. Anyway, it's a long story short, but I wanted to make sure I put in kind of that harmonization conversation. So as I mentioned, and I know I kind of went through the BC step code in Vancouver. Vancouver is kind of unique. They actually are a charter city. They have their own code. There's a lot to discuss about that, and I'm not getting into that here. But the Vancouver Energy Modeling Guideline is a really good example of a guideline that has become a code requirement. And the reason that has happened is because both the Vancouver's code will reference the Vancouver Energy Modeling Guideline and the province's code will reference the Energy Modeling Guideline. And so the requirements that are outlined by the guideline then become codified. Um, BC housing guideline for like part 3 buildings is a great example of it winds up illustrating the requirements for like a part 3 building that when you're working with BC housing. I'm actually really grateful. BC housing has spent a lot of time with us in the last little bit working on specifications and cleaning up the window and door side. So anybody from BC Housing, thank you very much for all the effort you guys are doing. We can see it. I'm acknowledging it. The Toronto Green Standard is interesting. I think it's gone through a bit of a ringer in Ontario because of some of the changes that there is an act that came through that made something like this guideline not applicable. There's push and pull there. I think Toronto is pushing back, and I think probably for the better in the sense that it's similar to the Vancouver Energy Modeling Guideline, where this is Toronto trying to say like we would like to take a more aggressive stance on this particular item. We believe we have the right to do so. And then industry guidance, when we get into installation, this is one of those where manufacturers installation guidelines ends up being a codified item because it gets called out. So yeah, again, guidelines are interesting in the sense of they wind up with power because acts and codes will call them out as requirements. So we're still in interior environment methods. So apologies, that was a bit of a sidetrack to get us back around, but I feel like this was important information just to start with. There are two test methodologies that we use in the window and door world in order to determine interior environment. And they are for the most part synonymous, meaning their test methodology is similar enough that they're viewed as the same requirement. In Canada, you can test your product through either schema method. So you have CSA 440.2, which is our Canadian method, and then there's NFRC, which is the US method. But both are synonymous. There's not a lot of differences between the two, with one kind of critical exception. It is much easier to understand what people have tested through NFRC than it is through 440.2, only because 440.2 doesn't have a central database of all of the tested products. So, in order for you to figure out if you need to validate whether or not a product has been tested, you need to go to each individual test lab and try to figure out where that information came from. Versus NFRC has what's called a CPD database. So anybody that sees a product that has NFRC, you can actually go to NFRC's site and look up their certified product declaration, or yeah, I think that's the right acronym. Somebody can correct me in the chat. Their CPD site will you can actually look up the manufacturer and look up all the different certifications that they have for their product for the various types. We're going to talk about the complication of that here in a bit, but for now, these are the two test methods. So those two test methods are going to provide us U value, solar heat gain coefficient, condensation index, and visible light transmittance. Your U value is going to be determined by a hot box or a guarded hot box test. So you're going to have a warmer interior space and a colder exterior space, and then dependent, you're going to be able to test, what the heat loss is through that element. Solar heat gain is you're going to have the visible light transmittance. So I think it's 390 to 730 nanometers, if I remember my numbers correctly. But in that space, that's your visible light. And then you're going to have a spectrometer or a spectral gadget that is going to help you understand how much solar heat gain you're getting through that glass. And it's going to be on a scale from 0 to 1. 0 being no solar heat was able to get through that, and 1 meaning all of the refracted heat and bounced heat was able to come through that. Windows are, I mean, there's a deeper conversation about this, but for the benefit of our market, we have to use low E coatings in Canada. And so you're going to have anywhere between like a 15% up to 60 or so percent amount of solar heat gain that you could have. I'll kind of touch on this in a little bit, but I just want to put this here. Solar heat gain is not a dial. It's defined by really limited elements. And so there are these kind of brackets of solar heat gain that you can have. It's not something that I can say if I want this particular metric, I can just kind of dial it up or dial it down, dial it down, dial it up. Condensation index is going to be mostly an equation based off of two temperature differences. And so you've got like therm and window are going to help you define what the potential condensation risk is to that product. It's not really used almost anywhere in the regulatory space. There have been discussions about using it, but at this time, I honestly can't say that condensation index is being used almost anywhere, but it is something the window and door manufacturers test. Visible light transmittance has definitely grown as a metric that we see a lot more. That both BC Housing has pretty tight guardrails around what they want to see. Architects have spent a lot more time on what they want to see, but visible light transmittance shows up a lot more now than they did, say, 5 to 10 years ago when I was starting in multifamily. All right, so I wanted to give some examples of energy performance labels so you guys could actually see what would be typical to see on site. Um, so energy performance labels are kind of funny in the sense of there isn't a like nice, yeah, this is the format you need to use every time. There are specific bits of information you need to use, but they can wind up being combination, like this one on the right hand side. They're like combination NAFS labels and a NFRC label. But it is worth noting the only metric here that is a regulated item is a metric U value. That needs to be on the label regardless. And so this like 1.10, 1.19, these are all items that absolutely have to be on there. They provide the solar heat gain energy rating, visible light transmittance, condensation index as, you know, these are things that we already tested for, so they're now available to you on the label. So the actual label requirements, whenever you're dealing with like a temporary label, so all products in Canada need to have a temporary label for both the energy efficiency and for NAFS. So you know, you're going to have a U value in metric that has to be there, the name of the manufacturer has to be there, and the certifier has to be there. Um, I'm going to talk in the next slide about permanent labels, so I'm going to just kind of put a pin in this particular one. But yeah, having a temporary label is an absolute requirement, and in BC, a permanent label is a requirement. I've given a couple of the recognized certifiers just so that people have an idea. You know, you can go. So when we're talking about CSA 440.2, again, you need to go through the process of actually looking at each one of the certifiers to figure out what, if you want to verify the information that you've been given, you got to go to these guys in order to figure it out. Ideally, you just ask your manufacturer and they will either give you the test labels or they will tell you who that certifier was. Um, so permanent labels. Come on. Um, it is not defined by any of the codes. The NBC doesn't do it, BCBC doesn't do it, BBL doesn't do it. So the reason why they're a regulatory item within at least BC is that the building officials of BC created an interpretation that pointed back to a Fenestration Canada labeling guideline that said that you need to have it. So this might be one of the most roundabout ways to create regulation, in my opinion, but in BC, permanent label is required. So if you're looking for a permanent label, the definition is that it's not intended for removal without destroying or defacing the label or the product. So a permanent label is going to be on the spacer bar, it's going to be on the glass, it's going to be on the hardware, or most commonly what I've seen is this gold label that sits on the inside of a sash. That's kind of the most common thing that you'll see. Um, but it is worth noting the rest of the country does not have this requirement. Though I will say, colloquially, the window and door manufacturers just see this as a requirement because if you have to sell your product into the US, you have to have a permanent label. So that's kind of where this like it has become a commonplace regulatory item actually without being called out for a regulatory item. So I think it's really important that we have a discussion about standard size versus project size. I think this is something that is just frankly kind of missed on the big scheme of things. But when we go through certification for our product, on the energy side specifically, we have a series of standard size measurements. You know, really in the energy space, we're dealing with an apples to apples comparison. You know, if you buy from window company A, they are going to be testing the same size type of configuration as window company B. So that gives you the ability as like the purchaser to see like, well, this company performs this way and this company performs this way. So like a casement, for instance, is going to be 600 by 1200 millimeters or about 23 and a half by 47 inches. So the weirdness there is that if you've got a project size that is bigger than that, Your center of glass value, whenever you're looking at windows, is significantly more, typically more effective than your frame values. So the further you get away from your center of glass, the less the poorer that window is performing, or the less resistive to thermal loss that window is. It is slower. It is slower at the center of glass than it is at the edge of the glass. Um, so if you've got like a really big window that you're putting in, and I would say in most of BC, our standard sizes at the like label compliance side is not really representative anymore of the stuff that we're actually putting into buildings. And the scaling actually changes the dynamics of that window pretty considerably. So like how well that window resists that loss and how much solar heat gain comes through that glass changes pretty considerably. So standard sizes are compliant across Canada. There are no expectations of not using standard sizes, even in Vancouver, where there was an item in the energy modeling guideline that asked for size-specific calculations. Um, there is a sunset clause now built into the VBBL for the next 2 years while the industry gets a size-specific calculator launched, which I am really happy to say that in the next luckily, Terry Admonson is on this call, and I believe the last time we had that conversation, it was like December 6th. It's going to be next month. We're trying to get a size-specific calculator launched. And so you can go to Fenestration Canada and you'll be able to take your standard size configurations, put the information into that calculator, and get specific size calculations for your building. And so I think that's a huge step forward personally, that the accuracy of the windows has always been a bit of a question mark. And, U value is one thing where I think there's kind of an acceptable delta within what happens in a bigger size window versus a smaller size window when you're thinking about thermal loss. But on solar heat gain, it is wildly different. And so I'll kind of get into that in the next slide, but expect that's coming. That will be on our site. So look for it by the end of the month in December or early next year, and you'll be able to start using that. There's also a guidance book that we're creating right now that'll be really helpful for kind of going through the process. It's great for like a multifamily project. We can run through that calculator in 20 minutes and give us exactly what the actual calculations are for the windows. So why this matters for solar heat gain. So let's take a casement window. The 600 by 1500 millimeters, kind of like what we talked about earlier. That window, if I run it through what's called a relative heat gain calculation, this is a way for me to look at worst case scenario for that glass in the west face of the building. That window is going to generate 441 watts of energy. So that's the equivalent of the laptop I'm currently using. Versus if I take a sliding door, like a 76-inch by 76-inch door, that same glass with the same frame is going to generate about 1,400 watts or almost 1,500 watts of energy. That's the equivalent of having a space heater in your room turned on high. So, like, just so that we kind of understand each other on this, is like, that's the difference when you are talking about one size versus another. And so, if we're not calculating this by size, we're actually missing the solar heat gain conversation, in my opinion, pretty aggressively. So, there's a whole nother presentation I've done on this subject. You can find it on our YouTube video from Fenestration Canada. If you ever have questions about it, again, feel free to reach out. I'm happy to talk about this one to ad nauseum. But this at least gives you some idea of why that size specific calculation matters and why it's kind of this growing thing. Okay, so I'm going to finish off this interior environment conversation with checking for low-E coatings. So I've got a couple things in this presentation that are like this. I want to give you guys something practical you can do on site to actually figure out if things are working. So we've had these funny cases where we'll get labels on a product and it'll say that they do a particular thing, and then they just won't do that particular thing, meaning like color won't be right, they are not performing as expected. And so one of the things you can do to check to make sure there's actually low-E coatings on the product is you can use a lighter. So if you've got a single low-E coating, you're going to see two flames. If you have two low E coatings, so pretty common in like a triple glaze system, then you're actually going to see four flames. And so that refraction with the lighter is going to help you understand how many low E coatings are actually on the glass. If you've got one flame as you're putting the flame up on the glass and you don't see those reflections, probably a good idea that the low E coatings are not there. ID9 is a hard coat that is applied to the interior surface. That's going to have a texture. If you can feel it, that's probably what that is. Otherwise, somebody screwed up and put their low E coating on the inside, and that's going to be weird and blotchy later, and it'll be really obvious. There's also low E scanners, so you can use a tool that'll tell you exactly what low E coatings are there. All right, so that gets us to the first of the interactive slides and kind of one of our first benchmarks. So I've got a project. The location's in Vancouver. It's a 6-story multifamily building. It's used as residential. So my question to you all is, now that we've kind of talked about interior environments and based off of what you guys think, what's the most important check you could do to de-risk interior environment compliance? Like, what can you do to make sure your building is safer when it comes to, the interior comfort of your building, or whether or not your products are actually meeting what is expected?
Do you see any of the answers there, Adrian?
I don't.
Okay, well, I can share them with you. I have them opened in another screen here. So we have sound mitigation, solar heat gain, understanding product, use of high performance windows, solar heat gain control, ensuring labeling on all windows and doors, low E coating inspections prior to install, overheating, use an energy advisor, U value and solar heat gain coefficient, check solar heat gain coefficient, change from sliding door casement window, verify window specifications and verify once installed, structural, U value, supplier feedback, window air tightness, labels, ensure specs accurate for building elements, and U value and condensation index.
Okay, that's great. And there wasn't a right answer there. I think almost all of those are directly applicable. It's really interesting to hear you guys kind of go through the solar heat gain as the focus. It's felt like that was kind of the majority of them. I hope I didn't lean too hard on that and it kind of skews the result, but I would say it's one of the, especially in Vancouver, in Toronto, and Montreal, it's one of those risks that I think are overcomable, especially on the Windows side. It's really a simple thing, in my opinion, to mitigate that you need to just prioritize a two silver versus a one silver type of solution. And I'm not saying that a one silver can't be really useful. So sorry, one silver is a single coat of low E coating. Two silver is two coats. If you've got more coats, then it is more resistive. And the industry kind of deals with it in a 3-coat, 2-coat, and 1-coat solution. So that's kind of why there's these gaps of solar heat gain coefficient that you're going to see, is that like a 3-coat is going to be anywhere between like a 0.15 up to a 0.25 type of solar heat gain, and then a 2 silver is going to be like a 0.26 all the way to 0.35, 36. Not typically 0.35. That's actually a bit of a misnomer. And then a 1 silver is going to be anywhere between like a zero point 0.4 up to 0.6, 0.65. Okay, well, excellent. Thank you guys for that, and thanks for giving me a rest on my lungs. What's the questions, Jenna?
All right, so this one's a bit of a long one, but I'm going to read it all out just for those folks who aren't able to join live, so can't see the Q&A. But Fred asks, as mentioned in the presentation, a common practice in Part 3 building is on-site water testing. It's a normal requirement that the architect and building envelope consultant expect in a project, which is normally part of project specs. Some municipalities in BC require Part 9 buildings to have a professional overseeing the envelope, an architect or envelope engineer. Understanding the installation is a major factor in the performance of the window system. How can a consultant or architect assess the window performance without having the system tested on site? Should they rely exclusively on NAFS labels, documentation, etc.? Do you see field testing being more common in Part 9 buildings?
Awesome question. And I've got a whole section kind of dedicated to it in the next. So after the next activity, I'll kind of talk about water testing. So I won't take the steam out of that too much. But to answer your question, yes, there is an increase of water testing for Part 9 buildings, especially in BC. There is some discussion I'll kind of get into about what to look for, what's appropriate necessarily when it comes to evaluating how effective a product's going to be. I'll even give you some dirty secrets that are behind that conversation. So give me another 20 minutes or so of this presentation and I will turn around and kind of get into that for you.
Perfect. And then this next question from Kim, it just is back a couple slides where you're modeling solar heat gain coefficient by window size, and they just ask what is the solar heat gain coefficient for the windows used as examples?
Yeah, good question. So for these, they're using a single silver. That means it's going to be like a 0.43, 0.44, kind of in that range. There's actually a whole chart that I could send you that gives you kind of a breakdown of, zero silvers versus three silvers, and when you're applying it to multiple surfaces. But for your benefit, this is going to be probably about a 0.44, 0.45 type of solar heat gain.
Wonderful, thanks. Those are all the questions, and I'll just give you a quick time check. It's 5 to 9.
Yes. All right. So we're gonna run through NAFS in as concerted an effort as I can. So exterior environment. Again, what we're talking about is the products are able to resist exterior load. This isn't going to be anything to do with like human occupant load. So like guard, for instance, is not defined by NAFS. And anybody on this call that has that confusion, again, feel free, reach out. We can have a long conversation about guard when it comes to glass and frames, and it's a whole other conversation. But what NAFS is supposed to do is supposed to tell us how is it able to resist snow load? How is it able to resist wind load? How is it able to resist torquing and pressure on its corners? How well does it resist airflow through the product? And then how well does it deal with water penetration when it comes to the product? So in the building code, this is called out in mostly 9.7. So 9.7 has a whole bunch of items that are related to it. There's also some call outs in part 3. It is worth noting, or part 5, in BC, we kind of have a unique opportunity where the building code is going to give us in a non-part 9 building the ability to engineer some of the tests that are related to NAFs or the things that might be slightly askew from what the testing environment is within NAFs. When we get to the national building code and the rest of the provinces, they've adopted the 2020 change, in which there is no additional engineering path that you can take outside of what's defined. Um, that's a much bigger conversation, but I think it's probably worth noting that in BC, you still have a fair bit of flexibility with the engineering world to determine what is appropriate, though NAFS Austin gives you some of the best methods that we have in our industry on how to deal with it. Um, so, so yeah, that's a little bit of where in the code world it exists. NAFS is the North American Fenestration Standard. It is how all of this is dealt with. NAFS is managed by the Joint Management Document Group, which is a combination of CSA and on the US side, WDMA and FGIA. So those three parties work at creating a harmonized standard between the US and Canada. Um, and I'll talk about S1 here in a second, but um, I kind of want to talk about a few of the basics around it. So PG is a performance grade. So this is a bit of a combination metric that you get based off of windows resistance to wind and structural pressures and water pressure and the location. So I'm giving a couple examples of what you typically see for different types of buildings. So like for a single family home, PG 15 through 25 is kind of expected for that range. PG 30 through 40 is kind of expected for a mid-rise or multifamily building. And then PG 50 plus is typically on high-rise buildings. Even saying that is a bit of a tricky thing, and I'll get into it in the next slide. Um, but you get into performance classes. So performance classes, in my view, is actually a better way in combination with performance grade to help define, what's appropriate for different buildings. So each one of the performance classes has gateways or gateway testing that they have to do. So for R, it's pretty simple. LC adds a little bit of durability around hardware. There's a few other tests that are involved. Between LC and CW, they start what's called the L over 175 deflection requirements. And, if it's kind of, I'll call it a miss in the engineering world, but when you get into multifamily, an engineer really needs to be able to say that the product meets that L over 175 in order for them to meet their own professional engineering requirements. But this NAFS, because of the way the standard is written and the way that the code kind of points to it, it actually allows the engineer to say, well, if you've got your NAFS testing and it's meeting the appropriate performance grade and it's meeting the specifications, I don't actually need to look whether or not it meets that L over 175. That's one of my little dirty secrets for the industry. I apologize to my industry. AW is complicated. In my view, it's very much designed for aluminum windows. It has changed actually a bit in the last iteration of NAFS, and it's actually brought some of the rest of the window world into it, but it had really strict limits that as a material type was only really achievable by aluminum, and then some of the fiberglass companies I think have gotten to a place where they're pretty comfortable in that space. So S1 is unique to Canada. S1 provides us a method of testing around wind and snow load that gives us information relative to locations in Canada. So that's a great follow-up into, Fenestration Canada has a calculator that you can actually determine what the appropriate PG rating is for your project based off of where it is and the type of project that it is. So if you go to our website, for anybody that doesn't already use this is a great way for you to determine what is appropriate for the windows. I oftentimes used to use this in multifamily buildings whenever there was kind of that debate about what was expected. To just give them the PDF printout that comes out of this calculator, and you give it to the architect, or you give it to the developer, or you give it to the specifier, and say this is probably what's appropriate for your project. So I can't speak highly enough of the tool. I think that was a great thing that we did about eight. Actually, I don't know how long ago that was. I think it's 8 years now, but it might be a little bit longer than that. All right, so getting into a bit of the complications around NAFS when it comes to what is expected. So let's start with a label. So the label is going to give you the information that's provided, and it needs to be on the label in order for it to be appropriate for the label compliance according to NAFS. So first is going to be your class. So you need to be able to call out, is this a light commercial? Is this a commercial? Is this an architectural window? Meaning, has it met those benchmarks that is expected for those different classes? And the PG rating, meaning it was able to resist a series of pressures that met this particular PG rating. Type is going to be like for the window that's kind of shown, this is a casement. So casement has its own tests expectations. And then this will give you the size in which that window was tested. So in the next slide, I'll kind of explain what happens when you go beyond that test size. Yeah, this is going to give you the max size that product can be built to. Then you're going to talk about different design pressures. So specific to that question that was just a bit ago, the pressure that's defined here is not the on-site test pressure expectation. This was what happened in a lab. And I will say for doors specifically, this water test pressure doesn't make a ton of sense because the way the lab's tested, they use a French drain at the bottom. And so that means a lot of the water buildup and the column of water that's putting pressure against that gasket is being drained immediately. So unless you're going to design all of your projects with French drains, I would say the test methodology between what's happening in the lab versus what you're getting on site are going to be different. It's really common for like a two-thirds type of expectation between what was tested in the lab and what is expected on site to be reasonable. That was oftentimes what I told people is that, if there's a lot of imperfections that happen on site that you just wouldn't have in a lab. Like you just have to imagine that people are trying to make that window as bulletproof as humanly possible when they're trying to get their numbers during the testing. Um, Air infiltration, a lot of this A3 type of work is actually now being replaced with actual metrics, but that's slightly different conversation. And then this at the bottom is going to tell you what it conforms to. So, like if you were to see this particular label on site right now, this is not meeting compliance. So, what this is saying is that this is a 44008 and 11. So, it was tested to these two standards. Where you need to be right now is 17 in order to meet compliance. And I would say if this product was going through the same testing schema that they were doing then, it would say 17 and 21. And then S1 would be 19. So that's what that label right now should say. And we're going to get a little bit into the complication of NAFS when it comes to being compliant, but yeah, let's go through the rest of the product types. So this gives you a bit of an idea of the various product types that you could be testing for, and each one of these is going to have kind of its own unique methodology for testing. So when I was talking about the size, so on the label, if you've got that max size, let's look at like example A. So we went to the lab and you test a operable window next to a fixed window. The window is 24 inches by 24 inches. Then you put a window on site where the operable gets shrunk and the fixed window increases in size to make up for that difference. That's okay. Like that window is still within compliance because the total size of the tested product is still within those parameters. Now, if you were to expand the size by height or by width beyond the tested size, that no longer is meeting the compliance. In BC, that would then require either another label that would be appropriate for that tested product, or it needs a Part 5 compliance path. So a letter of assurance from an engineer that that product is going to meet the project requirements given what they have for the NAFS testing. Again, throughout the rest of the country, that's not an option. You don't have that path. You have to test that product via NAFS. So I want to go through a little bit of combination assembly so you understand how complex this gets so quickly. So like let's look at the product on the left side. What this tells me is that on the left side of the product, they have a window that's, let's call it 18 inches by 36 inches. It was a fixed combination window. That window combination had some variance between those mullions if they did mullion testing. Let's just say for simplicity's sake, they've got this fixed window, it's tested to that size, that's appropriate. And then on the right-hand side, that would mean that they would have had to have had that operable fixed over fixed combination that they tested. So, based off of these last three slides, you can appreciate how this gets out of hand really quickly. That you wind up having to have all of these different test combinations, and it's not a cheap thing to do. Um, so you've got another window that kind of does this operable next to big fixed window. If you were not to have tested this configuration, but you tested like an operable, a fixed, yeah, so a fixed and an operable, what you'd have to do is put a label on this window and a window label on this window and a label on this window, all for separate test methods, in order to meet NAFS compliance. So I wasn't quite sure where to shove glass compliance into this, so this is where I'm going to do it. So in order for glass is one of those weird compliance items that is probably one of the more critical because if glass isn't meeting some of the standards of North America, we're going to feel it, meaning it breaks easy, it has wavy weirdness that we haven't seen in a while. Um, but you have to go through what's called IGMA certification in order for the glass to meet some of those strength requirements. So a factory has to go through that and test that their glass is meeting that compliance. And then if you've got like an IGU unit that is not tempered, it's meeting a 12.8 CGSB standard. So these two things have to be done, and it's actually kind of hard to check for that compliance. But what is easier to check for compliance is if you have safety glass on site, like a tempered piece of glass, or tempered or laminated, you're actually going to have a stamp on the glass in the corner, one of the corners, depending on how the IGU goes into the frame, that tells you whether or not that glass is tempered. This has got to be one of the easiest ways for you guys to check whether or not that tempered glass is there. So I kind of mentioned I wasn't going to deal with some of the safety glass requirements. A little bit right here. So there's a like glazing inside lights and indoors have to be tempered. Adjacent to doors, so side lights adjacent to doors have to be tempered. Bottom edge, this is incorrect. I'm going to fix this in another slide, but ignore this bottom section almost entirely. There is a 900 millimeter to the ledge. Too complicated to go over right now. I'm going to lose out of time. But if you guys have interest in the when guard gets applied and safety gets applied, please reach out. I will outline that in an email because I've had to do it many times, but that's irritating. So this etching in the corner, I've never heard it as a bug stamp, but as I was doing this presentation, apparently people call it a bug stamp. So tempered glass sitting in the corner, T designation. Ideally, it's in the bottom right corner or the bottom left corner, but again, it depends on how people put that IGU into the space. So this is our next project scenario. We're going to be in Toronto this time. It's a single family home, new construction, residential. So based on what you've learned so far, or what you've personally experienced, what are some exterior environmental factors that the builder should be focused on?
Perfect. So I just ran that poll and just kind of in the interest of time, I know we have 20 minutes left together. While the poll's running, I'll ask a few questions that have popped in the chat.
Perfect.
So Tamara just asks if you can, it's just about the requiring labeling on windows. She's wanting to know if you can use labeled glass to make your own frames in residential renovation scenarios.
Hmm. One more time on that.
If you, for the labeling requirements for windows, she's just wondering if the labeling requirements are specific to the glass or the glass in the frame and why the context there is whether you can use labeled glass to make
Uh,
your own frames in residential renovations.
Understood. And that's actually something I feel like I probably missed early on is when we're talking about compliance with NAFS labels or NFRC, these are all things that are frame and glass. Those two have to be together when we're talking about any of our label compliance. So you don't get a label for the glass and you put it into a random frame. That will not produce the results that are, call it, reasonable to assume on site. So yeah, it has to be frame and glass. And each one of those test methodologies are going to, if you're showing up and you're just putting a label on the glass and then you're putting it into the frame, that's going to be off.
Okay, perfect. And Casper asks, he's a registered energy advisor and he's seen a lot of window specifications over the last 4 years. And he says that he'll see windows that on a surface level are the same. Maybe they're double paned, one silver, argon glass, warm spacer, and vinyl, but you'll see pretty variable performance values with some windows qualifying for ES and others not qualifying. So he's just curious about what causes this variation typically between the windows.
Yeah, a lot of factors are going to play into that. So the spacing of the glazing matters, the way they dealt with their air tightness around the product matters, frankly, the quality of frame construction matters. It is a pretty variable conversation. this gets into what is the maturity of the manufacturer that you're working with, and how much do they have they invested into kind of understanding that, and what were their values as a company? It's like, what kind of market were they going after? All of those things kind of play. So sorry, that is a really general way to answer that one. But not all windows are created equal, even if you think the general categories are. Yeah, it's a good lesson to learn, I think.
Great. And then one more quick question here, and then we'll look at everyone's responses to the poll. For combination assemblies, should every element have its own label, or are there sometimes labels for combined elements?
So that really has to do with for manufacturers, if they test combination units, which I recommend, like a lot of times you have certain combinations that make a lot of sense for you as a manufacturer. You're going to have a label for that particular combination unit. You won't have it for like each one of the individual units if you don't have to. And I think that's really important. So again, going back to water testing is something I think a lot about. So I really appreciate that comment earlier. Like in a combination unit, a lot of times if you've got like an operable over a fixed unit, there's a drain channel that has to go from that operable unit down to the drain channel. And if it's not managed well, then you can get water in places that absolutely it does not belong. So, NAFS testing actually will give you a pretty good idea of how that combination unit is supposed to act under those circumstances. So, yeah, I'm gonna leave the rest for the water testing. Otherwise, I'm gonna lose time.
Okay, perfect. All right, so we had some answers to the question there. So, as far as exterior environment factors, what should the builder be focused on? So, some I'll just run through quickly what we heard here. So, we heard NAFS label, lab test just for reference, wind and rain pressures, terrain type, some more NAFS, performance grades and classes, labeling, testing on site, durability, Windows energy efficiency, correct certification/class for Windows based on type of project, solar heat gain coefficient, U value, also the facing of the opening, preventing sound transfer from the exterior, wind, rain, and temperature, moisture management, window tested size on the NAFS label, solar heat gain coefficient, and then just a couple more here. We've got labels, E-value, weather, moisture, humidity, and penetration, building envelope seal, wind/orientation/solar heat gain, air tightness, and U-value.
All right. That was quite a range. And yeah, that interesting. Those are great answers. There's some of that definitely is more interior factor, but all the same, I think those are all still pretty applicable. Um, all right. So I've got a whopping 15 minutes to go through. We kind of talked at the beginning before everybody jumped on how hard some of the 90-minute stuff is, and I definitely went off on tangents. So I'm going to do my best to give you guys at least 5 minutes at the end to have questions. So I'm going to rapid fire the last handful of these, which I'll try to lean into things that really matter. So, one of the things that we see a lot is kind of what we consider non-compliant states. So, there is a maturity or a variance of what we see in the non-compliant space. One of the most egregious is just not labeling your product at all. Like, I get there are certain things that make sense to not label. That being said, within our market, you need to have a label in the product. I don't know another way to talk about that. If you don't, then it should be flagged. And I think any HJ or architect or any of the building stakeholders probably need to know that. I have seen label mismatch, which is probably the most benign of all of them, which is you have put a label on, and a lot of times because of how many various labels there could be for the product, it kind of gets mismatched. The most benign is like in the factory, they just didn't put the right label to the right product. That happens, and I'm not sure that's really worth the regulatory effort to try to enforce it. But it can happen. Deceptive label happens, unfortunately, where worst case that I've heard is that a window on one building, they had taken the labels from the building next door and just like ripped them off and put them on that window. Um, that's that is ridiculous. I think there needs to be mechanisms within the market to hold those type of people accountable. That there's so much money involved in having to go through all of this testing, and there's a lot of information kind of at the depths of this. So if somebody's abusing that system like that, I think there needs to be some repercussions. Product misalignment, it happens. It's kind of similar to label mismatch. I've got a casement window and a fixed window. I've kind of mixed up those labels. Um, what I would do if I were in the shoes of a builder or an architect or somebody that cared about this, I just asked to make sure that the information that I have about that window makes sense for the application. But it's worth asking the question. And so when it comes to like the project journey of what it means to be label compliance, it's like first off, the products obviously have to be labeled, they have to be tested, they're on site. There's a whole bunch of verification at the design phase of a project. When you're bringing on a window and door manufacturer, you should be asking, would you provide me some of your NAFS testings that are aligned with what you provide for this project? Like, hopefully some of the basic information you've gotten here, you can kind of decide between the calculator at Fenestration Canada or the NAFS calculator at Fenestration Canada or some of the penetration examples that you have kind of an idea of what you're hoping to get out of the project. And then ideally, you're verifying it at site. Like the product that you bought has the label that's appropriate, and like that's the absolute best case scenario that can happen. Um, so I've talked about specifications. I want to kind of just lean into specifications or critical contract documents. It is really, really, really important that the specifiers and the architects are not putting specifications out that don't make sense. I see way too much copy paste in that world. It really needs an oversight, and I realize how much is going on in the background, and specifications are the last thing anybody wants to read through, and most of it none of us understand unless you've spent time in that space. But if you don't, then reach out to some suppliers, reach out to Fenestration Canada, let us help you go through some of that because this is a contract document. I can't tell you how many times I had to fight builders on the specification called out something ridiculous, and then I was asked to meet it, or I was being told, why are you not meeting it when the energy advisor asked for something that was slightly ridiculous? No offense to energy advisors on this call, it just happens. But I just want to lean into project specifications are really important as we get into like OITC, VT, solar heat gain numbers. This is the specifications where these things are going to show up. So if the acoustic numbers don't make sense or the expectations around acoustics don't make sense, you're going to put the supplier in a really uncomfortable spot to have to deal with that. Visible light transmittance. A lot of what I see with VT numbers is that they're calling out center of glass VT numbers and not combination assembly, like meaning frame and glass combination. Like if you're only getting center of glass, that means something very different than like I incorporate the frame as part of that calculation. So that's really important. And then again, solar heat gains pretty much only going to show up in specifications. I was going to spend a little bit of time talking about STC versus OITC, but I'm going to kind of gloss over this and give you a broad stroke. STC is essentially inter-party wall type of dynamics, meaning between this wall and the wall on the other side, the sound penetrates a certain amount. And so there's a test method that defines that. OITC is outside, inside, or outdoor, indoor transmission class. So that has to do specifically to the sounds that are outside of your building versus the resistance that glass and that frame has to it. OITC is something that's often called out in projects. I There's a lot of work, in my opinion, in the window and door industry to get to a place where this conversation makes sense. Right now, it's being done haphazardly, meaning like the testing is haphazard. It's really hard to get the right information. Um, and frankly, the sound needs to be defined by the project site because there's different sounds that have different frequencies that impact the choice of windows differently. Um, yeah, we could have a lot more conversation about this, but for the benefit of time, because install is important to me, we're going to kind of glaze through field testing requirements. As I mentioned, it is really common for 2/3 to be kind of the performance expectation. So let's say I sent a product in for NAFS testing. It came back as, um, you know, 700. And so what I want to do is I want to meet like a 460 in order to meet that two-thirds expectation. That's usually reasonable, but this gets back into like, did the manufacturers apply their labels appropriately from NAFS? Because if they have certain configurations that don't represent the configurations that they're giving, then they could have aspects of that testing that just isn't representative of what you're going to get on site. So this is where like that NAFS label compliance versus what you're asking for test pressures is really important to get in combination. Um, so the test method is E1105 currently. That's the only one we have. There is a 440.8 that's coming from CSA, which I think is an improvement from E1105. I'm really hopeful over the next 5 years or so we'll start to see that trickle into specifications. But yeah, I'm going to leave it to you guys to ask more specific questions about field testing. Um, it is one of these weird areas where currently there is just no professionals at the water testing side unless you're getting an envelope consultant involved. And I will just say BC is doing a great job on this. I think many of the sites have adapted and matured to a place that water testing is reasonable. I think everybody in that sphere, anybody that's done enough water testing knows that that is a team effort. The GC, the envelope consultant, the water, the window and door manufacturer, and the installer should all be on the same team. Like we are working to figure out how to make sure that works. When the pointing starts, that's where it all kind of breaks down. Like we stop actually working towards a solution. It just becomes who's the most liable for this because it's really expensive to start doing testing on an entire building. So there's a lot of conversation we could be having about water testing, and I will leave it to you guys to ask more questions about it. Air tightness testing is becoming more common, oftentimes is in specifications. Um, there is lab testing and field testing again. They are two different things. There technically is field testing for products specifically. It's called ASTM E783. I've never seen it. If anybody has seen it, I'd be really curious. Whole building testing is a lot more common. And again, in BC, we have a qualification path through Passive House for the VBBL. And then we also have like a typical air tightness requirement, which would be the CAN CGSB 149 or the ASTM E779. Um, what you're trying to do is get a total air tightness. And what I kind of like about what I've seen from projects for air tightness testing, again, this should be a team effort. Like your idea isn't to try to beat up on any one particular element. It's try to figure out where the air tightness loss is, because that's how, in my opinion, one of the absolute best things we can do for a high performance building is to get the air tightness right. Like if you can figure that out, the rest of it gets better. Now, that being said, the rest of your envelope details need to be like spot on. Anyway. All right, so installation. There is a reference in the NBC for 440.4, which is the installation standard. It's not direct. It is getting better in the future. There is some description about sill drainage and a little bit on rain screening. Um, I highly recommend documenting throughout the installation path because it's one of those weird things that you cover up pretty quickly with the rest of the building materials. Um, the common issues that I saw were like poor air and water barriers. So like when you're applying the sill pan, like the non-permeable pan for a window, fish mouthing is really common. Like if you don't apply the corners correctly and get the details in, this is a BC unique problem, but the whole metal sill angle, at the back of the window, is really hard to detail, and people screw that up a lot. So I can't emphasize enough. Take pictures during that first set of the sill pan if you can't. Um, Non-continuous interior seals are a problem. Most of the country uses spray foam for their installation interior method. I have some serious reservations about that. I don't have time to go into that in detail because it's a gripe. But making sure your interior seal is continuous is absolutely critical. Another item that is really important is that your rough open framing has enough space that your window can deflect as appropriate to the building. The building's going to shift and the product is going to shift. If you shove a window into a wall, as I used to say, the wall's not going to, or the window's not going to win the battle between the wall and the window. The wall is going to crush that window every time. And worse, when that happens, the window is not going to recover from it. So it's really important that you provide rough open spacing appropriate for a window. So that's going to be anywhere between a 1/4 inch to 3/4 inches, depending on the manufacturer that you're talking to and the type of attachment method they're using. Um, Windows being in level, plumb, and square are critical. And I've run out of time. This is like, I'm very sorry. So just going through a couple quick things. Solar heat gain's coming. Renovation is going to be a thing the next code cycle, so expect some alterations to existing building changes. Fire resistant glazing is a conversation we're having in the background. Embodied carbon is a huge conversation. I gave you a bit of a critical field inspection checklist. I provided this PDF to Jenna, so it'll be available to you guys. And there are a series of resources I've provided from Fenestration Canada and from a couple others. Um, and that is how I'm going to wrap this up. And here's my email address.
Perfect. All right. I know it was a lot of information to go through, so I appreciate it. And yeah, we'll be sharing out these presentation slides, so you'll be able to kind of review those last few slides in more detail on your own time. All right. Okay. Well, thanks again, Adrian. Really, really appreciate those insights. And thanks everyone for taking time out of your morning to join us. And we'll see you next time.
Thanks for having me.